Hey guys, this is 6.1. We are talking about factoring. We're going to do 6.1, 6.2, 6.3, 6.4, 6.7, and then you're going to do the exam. This is about factoring polynomials. Remember, poly just means many. So polynomial just means that your problem has more than one term. One term would be a monomial, right? Polynomial is more than one term. Factoring is closely related to multiplying polynomials, so that's why we're putting them all together. It's kind of the opposite of multiplying, right? If you want to find a greatest common factor, you would divide a polynomial, and then we're going to be doing something called factoring by grouping. All right. So I've written on this a little bit because I started the video and then I started it over because I felt like I got confusing. So hopefully I don't get confusing in this version. So we have decided, well, let me first introduce section 6.1. We're factoring with the greatest common factor. And then by the second half of the lecture, we're going to factor by grouping. So here, we're going to look at, for example, 18x cubed minus 4x squared plus 10x. And we're going to say, what is common to 14x cubed minus 4x squared plus 10x. 18 and 4 and 10, I'm pretty sure I can divide out at 2, right? X cubed, x squared, and x, I can divide out the letter x. All right, that's what we mean by factoring. Factoring by grouping would be something like 4x plus 40 plus xy plus 10y. We have more terms, right? Here we only had 3 terms. That doesn't really matter. What matters about this one is we have those 4 terms, and I don't have, here I have the number 2 to divide out and the letter x to divide out. 4x and 40 I can divide by 4. 4x and xy I can divide by x. 4x and 10y I can divide by 2. But there's nothing that I can divide all of them by. I can't divide 4x and 40 and 10y and xy all by one number, right? So this after question 23, we move on to factoring by grouping, because what we're going to do is we're going to group them. Instead of 4 terms and we're dividing them all by 2 or by x, we're going to take the first half of the problem and divide out a 4, take the second half of the problem and divide out a 1. Okay, that's what factoring by grouping means. Before we get to factoring by grouping, we need to talk about the greatest common factor. Okay, so we know that numbers being multiplied together are known as factors, right? To factor, your answer is always something times something, right? Something times something equals what you started with, right? The factors of 9 are 3 times 3. So 3 times 3 equals 9. 3 times 3 is the factored form of 9, okay? So numbers being multiplied together are known as factors, and the result of the multiplication operation is known as the product, right? If I had the number 6, 2 times 3 are the factors of 6. Well, I should just say 2 and 3 are the factors. 6 is the product of my factors. Okay? So when we say 2 times 3 is 6, we have multiplied, right? If we go backwards, we are factoring. 6 is 2 times 3, right? So when an integer, a number, is a factor for every term in the group, that is a common factor, okay? So common factor a factor for each term in a group. Okay, so that's what a common factor is. A factor is just the opposite of multiplication, right? I can divide it out of the term. I can divide 3 out of 9, so 3 is a factor of 9. I can divide 2 out of 6, so 6 is a factor, 2 is a factor of 6, right? So common factor is a factor for each term in a group. the greatest, so the only difference here is we're adding greatest common factor. You have a factor for each term in the group. If you have two factors for each term in the group, the greatest common factor is the largest number. For each term in a group. Okay, so what we want to do is we want to factor each number completely, create that list of factors, and then find the biggest factor of all of the terms. Okay. So that's the definition of a greatest common factor. The largest integer that is a common factor for each term in a group. If it includes variables, you're also going to decide that it is the variable with the greatest exponent, okay? X to the third and X to the seventh, for example, we can divide out the smallest exponent. What's the smallest exponent in this case? It's X to the third. If I divide out X to the third from X divided by X to the third, I just get 1. X to the seventh divided by X to the third is X to the fourth. So what we say is X cubed 1. Well, it's not even a math problem. X cubed X to the fourth, right? X to the third is X cubed times 1. X to the seventh is X cubed times 4. So my greatest common factor X to the third. Okay, all we're doing is selecting it out. There's nothing to do because there's not even a sign between them. It's just a list. Okay. So how do you find the greatest common factor? You divide. Well, what I would do is I would put each integer into its prime factorization, and then I would pick out the biggest prime factor. Okay, that's how you find the greatest common factor for a list of integers. Prime means you can only multiply it by itself times 1. 3 is a prime number because you can only multiply it by 3 times 1. It's a prime number. 2 is just 2 times 1. 9 is 3 times 3. So it's not prime. 9 is not a prime number. 3 is a prime number. 4 is not a prime number because you can divide it by 2. So a prime number means its only factors are itself times 1. Every number you can multiply by itself and 1, but with most numbers, you also get other factors, okay? So if we want to find the greatest common factor for this list of 196 and 35, what are we going to do? We are going to factor each number. Good? So if we factor 196, what do we get? Or, better question, how? How do we factor 196? You can either make a list of primes. Like 1, 2, 3, 5, 7, 11, 13, 17, 19. Okay, now I don't even know. All right, Google, tell me. I paused the video and Googled it. 23, 29, 31, 37, 41, 43, what else do we need? All right, so you can make the list of prime numbers, and then you can just take 196 and start dividing it by prime numbers, or, right? If you would prefer, you can just start dividing it by, like 2. You can either start at the bottom of the prime number list, not with 1. 1's not a prime number. Or, hold on, 59, 61, 67, 71. Again, this is still from Google. All right, those are the prime numbers under 100. You can either start at 2, you can start at the top closest to the number you're starting with, 196, or you can just start with what you know 196 is divisible by, okay? So let's do 35 first, yeah? 35, if I look at my list of prime numbers, well, 35 divided by 31 is not going to be possible, right? 35 divided by 29, no, we need something half the size of 35, right? 35 divided by 23, I don't think so. 35 divided by 19, no. 35 divided by 17, no. 35 divided by 13, 35 divided by 11, 35 divided by 7. Oh, it's 7 and 5. So if you start with 35, the smaller one, right? And I start dividing by prime, beginning with the biggest prime, I get 7, and 7 times 5 is 35. Those are both primes, so that is the factored form of 35. 35, the factors are 7 and 5. Now, good thing we started with the easier one. Now I would take 196 divided by 7, take 196 divided by 5. I don't think it's going to be divisible by 5, right? Because if it was divisible by 5, it would end with either a 5 or a 0. So take 196 divided by 7. You get 28. So 196, the factors are 7 and 28, right? So those are the only factors of 35 besides, because we're going to ignore 35 times 1, okay? So we're going to ignore the number and itself. So the only factors of 35 are 7 and 5. The only of those two factors, the only one that could possibly be common to 196 is 7. So the greatest common factor is 7. Why would I do it that way and not just say 35 divided by 2, 35 divided by 3, 35 divided by 5 and get it that way? Because there is a danger that if you take a number that is small, there will be another number that you can divide out of it. But you are welcome to start on that side, or you're just welcome to say, well, I know that 35 is 7 times 5, so I'm going to start with 7 times 5. Okay, the important thing is finding the factor, start with the easiest number to factor, and then take those possible factors and start dividing the bigger numbers by those. Okay, so in this case, we have 12. Right? Again, you're welcome to start at 2 instead of starting way up here at the, what would it be? 5, no, 3, yeah, 2. Right, so you can start at the bottom. 12 is 2 times 6, but 6 is 2 times 3. So the factored form of 6 is 2. So the factors of 12, the prime factors are 2, 2, and 3, right? But 6 was also a factor. Then we take 20 and we say the factors of 20 are, again, you can start at 2. 20 divided by 2 is 10. 10 divided by 2 is 5. So the factors of 20 are 2. Well, I guess you don't need to write 2 twice. 2, 2, what do you do? 5. I said 5 and wrote 10. Darn it. The factors of 20 are 2, 2, 5, and 10. And then we've got the number 39. Well, 39 is not up here, so we know it's not a prime number, so we got to divide it by something. I'm going to start with 3, right? Because it's not an even number, so it can't be divisible by 2. So I'm going to take 39 divided by 3. 39 divided by 3 is 13. Is 13 a prime number? Yes, because you can't divide 13 by anything, right? So the factors of 39 are 3, and 13. Good. 2, 2, 3, 6, 2, 2, 10, 5, 3, 13. So 12 and 39 have a common factor of 3. 20 and 39 don't have any common factors. 20 and 12 have common factors of 2, and 2 times 2 is 4. So you can actually divide out a 4 from 12 and 20. You can divide out a 2 from 12 and 20. You can divide out a 3 from 12 and 39, but there is no number common to all 3 of those lists, okay? So we have to say that there is no greatest common factor, or you could say greatest common factor of 1. You can divide 20 by 1, you can divide 12 by 1, you can divide 39 by 1. There's no other number. All right, the next one is 42x and 7. Remember, 42x just means 42 times x. So when we're factoring 42, we're just going to also include an x at the end. 42 divided by 37, 30, 29, 23, 19, 17, 13. 42 divided by 13. No. 42 divided by 11. No. 42 divided by 7. Yay! 42 is 7 times 6. 7 and 6. 7 is a prime number, so we don't do anything further with that. We know that 6 is just 3 times 2. So the factors, 42x. The factors are 7, 6, 3, 2, and x. Every number, where did the x go? All right, I'm already writing it. 42x the factors are 7, 6, 3, 2, and x. All right, and what was our other term? 7. Oh, well, we should have started with 7 because there's only 7 and 1, right? So our greatest common factor of 42x and 7 is 7 because I can divide them both by 7. Good. We already decided that the greatest common factor here is x cubed. Why? Because we said that x cubed, the factors are x cubed becomes x times x squared, right? X squared becomes x times x. So the factors are x squared, and x cubed times 1. And then x to the 7th, the factors are x squared, x to the 3rd, x to the 4th, x to the 5th, x to the 6th, and x to the 7th, right? Because x to the 7th times 1 is x to the 7th, x to the 6th times x is x to the 7th, x to the 5th times x squared is x to the 7th, x to the 4th times x third is x to the 7th. So x to the 7th, all the factors are anything that's a multiple of x that is equal to or less than 7. For x to the 3rd, the factors are anything, any value, any multiple of x up to x to the 3rd. So the greatest common factor on this list is x to the 3rd because it's the highest x to the 3rd can go. So just pick the biggest exponent, and that's your greatest common factor. The biggest exponent of that base. Or sorry, I said biggest and I meant smallest. Take the smallest exponent, and that's your greatest common factor. They all have the same base, x, and x. Takes the smallest exponent, x to the 3rd. X to the 3rd divided by x to the 3rd is 1. X to the 4th divided by x to the 3rd is x. X to the 5th divided by x to the 3rd is x squared. So those are all those are all multiples. You can divide out x to the 3rd, delete the beginning of those previous two sentences, take all of those, divide out x to the third, and you get a value of x or the number 1. That's how you know it's the greatest common factor. Number 8, they are now combining numbers and exponents, or sorry, numbers and variables without exponents, interestingly. So what I do is I look at the numbers separate from the variables. Okay. We have 28. And again, you're welcome to use the list of primes or not. Okay, it's up to you. So 28, if you just wanted to start with a small number, 28 divided by 2 is 14, right? So 28 becomes 2 and 14. 2 just remains 2. 14 is 7 and 2. 7 is prime. So the factors of 28 are 14, 7, 2, and 2. 2 times 2 becomes 4, right? So that's another factor. The 2 times 2 becomes a 4. So here we said 12, the factors are 2, 2, 3, and 6. But because there are 2 2s, we can also add a 4. The factors of 20 are 2, 10, and 5. Because there are 2 2s, we can also add a 4. What are the other parts? 28, 6. 6 is 3 times 2. Oh, sorry, we're using commas now. And then 21 is 7 and 3, right? Good. Is there anything common to all 3 of them? 21 has 7 and 3, 6 has 3 and 2, 28 has 14, 7, 2, and 4. There is no common number. Okay. So we only have the variables. So this one is 28xz, yz, xyz. X, there's no x here, there is an x here, so x cannot be a common factor because x is not common to the 6yz. Z, 28xz, 7, 6, yz, 21xyz, z. What is the z? It is common to all 3 of the terms. What is its highest power? It's just z to the power of 1. So the greatest common factor, not that, the letter z. The greatest common factor is just the letter z raised to the first power. Because if I take 28xz divided by z, I still get 28x. If I take 6yz divided by z, I get 6y. If I take 21xyz, I divide it by z, I get 21xy. So what can I take out of each of the 3 terms? Okay. The shortcut to finding the greatest common factor of variable terms. So don't look at the if you're not looking at the coefficient, it's the smallest exponent of the common term will be your greatest common factor. That's how I would describe that shortcut. Okay. So let's keep going. We have a number, a coefficient in front of the variable m cubed, a coefficient in front of the variable m to the 7th. So the greatest common factor of m to the 3rd and m to the 7th is m to the 3rd, because that is the smallest exponent. M to the 3rd divided by m to the 3rd is 1. M to the 7th divided by m to the 3rd is m to the 4th. 42x divided by 7 is 6x. 7 divided by 7 is 1. Okay, so that's how you can go back and check that your greatest common factor is a factor. So just the variables, m to the third and m to the seventh. The greatest common factor is m to the third. Now we want to look at the numbers 21 and 189. Okay, again, you're welcome to use the prime list or not. Okay, if I have a bunch of really big numbers, I like to use the prime list because it might be faster. If I have a small number and a big number, I like to start with the small number and then just check if any of the factors of 21 are, if 189 is divisible by any of the factors of 21. So let's start with 21. 21 becomes 3 times 7, right? So the factors of 21 are just 3 and 7. The factors of 21, m cubed. The factors are just 3, 7, m cubed, m squared, m to the first, right? Also, oh goodness, sorry, it's already problem 10 and I never explained this. You can take 189 and see if you can divide it by 21. 21 is a factor of 21, right? That's how we got over here with the greatest common factor is 1. Because I haven't been counting the number of times 1 as a factor pair. I apologize. So let's take 189 and divide it by 21. Oh, yay, just in time. Very late, but just in time. So 189 divided by 21 gives me 7. Sorry, it gives me 9. 21 m cubed divided by 21 gives me 1. 189 divided by 21 gives me 9. So my answer is that 21 is the greatest of all common factors between 21 and 189, and that m cubed is the greatest factor between m cubed and m to the 7. Okay, so when you have really big numbers, like 196 divided by 35, oh, that didn't exactly work, right? So we had to keep going. 35 is 6 times 7, so we'll take 196 divided by 6. No, 196 divided by 7, yes, okay? So definitely start with the number itself. I apologize for getting all the way to 10 without teaching you that. All right, here we have, it's kind of hard to see. Here's our first term. Here's our second term. Well, I can even tell what each term is. Here is our third term. And here is our fourth term. Good. So what we have is x to the 9th, y to the 9th, x to the 8th, y to the 8th. If we just look at those two terms, our greatest common factor is, so this is just a side note, our greatest common factor would be x to the 8th, y to the 8th, because those bases are common to both terms, and we're going to take the smallest exponent. Good, but we need to keep going. X, y to the 9th. X, y to the 9th. Now, if we look at all three of those, so it's no longer x to the 8th, y to the 8th, because this one is just x. So our greatest common factor for x to the 9th, x to the 8th, and x is just x, because that's our smallest exponent. Y to the 9th, y to the 8th, y to the 9th, x, y to the 8th. So it's changed from, in this group, it was x to the 8th, y to the 8th. In the group of 3, it's x, y to the 8th. And then we include the last term, x to the 5th, y to the 6th. So that can't change the fact that x is our greatest common factor, because now we have to look at all of them, right? They all have a base of x, they all have a base of y. Here's a 9, an 8, a 1, and a 5. That's just a 1, it's the smallest one, right? And then of our y's, they all have a base of y, 9, 8, 9, 6. X times y to the 6th is the greatest common factor for number 11. Okay. All right. what if, so we have practiced greatest common factor. What would it mean if I asked you to factor out the greatest common factor? To factor out the greatest common factor means to divide all of the terms by the greatest common factor. My greatest common factor is x to the third. If I divide x to the third out of x to the third, I get 1. If I divide x to the third out of x to the seventh, I get x to the third times x to the fourth. Okay, that's what it means to factor out. Good. So the answer sheet says to factor a term means to rewrite the term as a product. So to factor out the greatest common factor from the polynomial means rewrite the polynomial as a product or a multiplication problem, including the greatest common factor and whatever is left over. You pull the greatest common factor out of each term and you put it in front, right? So if I had 6x plus 9, I need the greatest common factor, 9xy, the greatest common factor we've decided, 6 you can divide it by 3, 9 you can divide it by 3 is 3. You can factor out an x. So, oh, sorry, the greatest common factor is 3x. To factor out the greatest common factor means you're going to create a multiplication problem. This is right now an addition problem, right? You're going to create a multiplication problem. 6x is actually 3x times 2. 9xy divided by 3x is actually 3y. That is what it means to factor out. So I took my polynomial, I found my greatest common factor of 3x, and I divided it by that. I divided each term by my greatest common factor. And what I got was, but my answer isn't just 2 plus 3y, it's 2 plus 3y times the greatest common factor. And we can check that by just reversing it, all right? So I factored out the greatest common factor, and then I can re-multiply it to make sure 3x times 2 is 6x. 3x times 3y is 9xy. So that's what it means to factor out. What do we call a polynomial that can't be factored? Is prime, just like a number that can only be factored as itself times 1. Okay? So if you have tried everything and there's and you can't find any factors of a polynomial, and there's the answer box, and then there's also a button that's just click next to the word prime. If you cannot find any factor pairs, you just say it is prime. Okay. All right. So factor out, don't just find the greatest common factor, but factor out the greatest common factor from the polynomial. I'm going to do this the way that I forgot to teach you until number 10. You have 120x and 20, divide them both by 20. 120 divided by 20 is 6. 20 divided by 20 is 1. Okay, I cannot divide any x out because there is no x in the 20, right? So there's no way to factor the variable x, but 120x and 20 have a greatest common factor of 20. I'm going to take that 20 and I'm going to pull it out. So 120x divided by 20, we decided is 6x, right? So my greatest common factor goes on the outside. And then inside there, we take the answer to 120x divided by 20 plus 20 divided by 20. 120x divided by 20 is 120 divided by 20, 6, and the x, okay? Don't ignore the x. That's a plus sign, so we're gonna leave it a plus sign. 20 divided by 20 is 1, right? It's not 0, you have to leave a placeholder. If you just don't include it, then if you said it was 0, right? 20 times 6x, and then 20 divided by 20 is 0. 20 divided by 6x only gets you back to that 120x. And it doesn't give you that missing plus 20. So don't leave off the 1. Okay. here we have 18x cubed minus 4x squared plus 10x. What are the factors of 18, right? And do not hesitate if you're in a hurry or you find this annoying. Don't hesitate to Google what are the factors of 18, okay? 18 is 9 times 2, right? 9 is 3 times 3. So the prime factors of 18 are 9, 3, and 2, and 18, and 1, sorry, gosh. Right? 4, 4, 2, and 1. 10 is 5 and 2, right? 10, 5, 2, and 1. Good. Is there a factor common to 18, 4, and 10? 9, 3, 18, 9, 3, 2, 1, 4, 2, 1, 10, 5, 2, 1, 2. What about the x's? X cubed, x squared, x. The smallest one is just x. So my greatest common factor is 2x. Good. And then I'm going to divide that out of each one. 18 divided by 2 is 9. X cubed divided by x is just x squared. Negative 4x squared divided by 2x. Negative 4 divided by positive 2 is a negative 2. X squared divided by x is x. 10, positive 10 divided by 2 is 5. X divided by x is just 1, right? X divided by x is 1. Anything divided by itself is 1. 1 times 5 is 5. So I said we can't leave that as a 0, right? We leave it as a 1. 20 divided by 20 is 1. X divided by x is 1, but 1 times 5 is 5, so I just leave it as 5. That is factoring out the GCF from the polynomial. You're also welcome to go back and multiply the 2x to make sure you end up with 18x cubed minus 4x squared plus 10. Number 16, 20x cubed y plus 36xy to the 6th. So let's look at just the x and the y. Just the letters, because we do the variables different, right? X to the 3rd, y, and then x, y to the 6th. They both have x base and they both have a y base. The smallest x base is just x, power of 1. That's our smallest x, right? What's our smallest y? We have y to the power of 6 and y to the power of 1, so we're just going to call it y. So for our variables, the greatest common factor of x to the 3rd y and the term y x to the 6th is xy. And if there is no common factor between 20 and 36, it's fine to just divide out the variables. That is perfectly reasonable if that is the greatest common factor. However, we have the numbers 20 and 36. Start with the smaller one. 20 becomes 10 and 2. 10 becomes 5 and 2, right? So the factors of 20 are 20, 10, 5. The 2 times 2, right, is 4. And the 2 by itself, and the number 1. Those are the factors of 20. Feel free to also Google it if that's better for you. Now take 36 and just start dividing it by those numbers. 36 divided by 20 isn't going to work, right? No. 36 divided by 10 is not going to work, right? No. 36 divided by 5 is not going to work. No. 36 divided by 4. 36 is 36. 36 is, for example, 6 times 6. Right? So 36, the factors are itself, 6, 3, 2, but also there are 2 3s. That's also the number 9, and there are 2 4s, so that's 2 2s, so that's also the number 4. So those are all the factors of 36. 36, 9, 6, 4, 3, and 2. And what is the greatest common factor? We also just took 36 and divided it by 4. So we said our greatest common factor is 4. So if we factor out the greatest common factor, that means we're going to factor out 4xy from both. 20 divided by 4 gives me 5. X to the third divided by x gives me x squared. Y divided by y makes the y disappear. Plus 36 divided by 4, what did we say it was? 9. 36 divided by 4 is 9. X divided by x, the x's cancel. Y to the 6th divided by y is y to the 5th. Do it in reverse if you want to check your work. Okay. 29, x to the 9th, y to the 8th, negative 64, x to the 6th, y to the 6th, 48, x cubed, y cubed. So let's just look at the variable x first. We have x to the 9th, x to the 6th, x to the 3rd. I'm going to say that that's x to the 3rd. Okay. For y, we have y to the 8th, y to the 6th, y to the 2nd. I'm going to say the biggest of those is y to the 2nd, or sorry, the smallest. I would say the biggest. Y to the 2nd. You want to pick the smallest variable of the smallest exponent of the variable that is common to all 3 terms. Okay. So not counting the number 24, negative 64, and 48, we are dividing out x to the 3rd y squared, x to the 3rd y squared, x to the 3rd y squared. What's the last term? All right, now we have 24, 64, and 48. 64 divided by 24. No, that's too bad. All right. $24. You can do 2 and 12, right? You can do 12 is 6 and 2, and then 6 is 3 and 2, right? So 24 has the factors of 24, 12, 6, well, how many 2s do we have? 3 2s in its one factor tree means that 24 is divisible by 2 times 2 times 2. What's 2 times 2 times 2? 8. 24 divided by 2 times 2 times 2 is the same as 24 divided by 8. So if you have a repeating prime in there, you want to count it as itself, as the number 2, and as 2 times 2 times 2. Itself times the number of times it appears on your factor tree. Okay, so we have 24, 12, 8, 6, 3, and 2. Those are the factors of 24. All right, we already tried to divide 64 by 24 and it didn't work. Let's take 64 and divide it by 12. So I'm just going to go down that list and see if any of them are divisible, if 64 is divisible by any of them. I guess I should say negative 64. It's not divisible by 24. It's not divisible by 12. Is it divisible by 8? 64 is 8 times 8. Negative 64. The factors are 8. And we only need the common factors between 24 and negative 64, right? 6? No. 3? No. 4, sorry. So if it's 8, it also has to be 4. So 2 times 2 is 4. 2 times 2 times 2 is 8. So we have 4 is a common factor of both 24 and negative 64, and 8 is a common factor of negative 64 and 24. And then, what's the third term? 48. Oh, sorry, the number 2. Because it's an even number, you can also divide it by 2. So why did I find all of them instead of just the big ones? Because I want to make sure that there is common to 24 and negative 64 and 48. So 48 divide, in case it's not divisible by 8, we can also go on to check 4 and 2. But it is divisible by 8. So I'm going to say that the greatest common factor is 8. Eight x to the third y squared is the greatest common factor for numbers such as this. Good. 24 x to the 9th y to the 8th divided by 8. 24 divided by 8. 3. X to the 9th divided by x to the 3rd is x to the 6th, because we're just subtracting. Y to the 8th divided by y squared is just y to the 6th. And then negative 64 x to the 6th, y to the 6th. You want to make sure you include the negative. Negative 64 divided by positive 8 is a negative 8. X to the 6th divided by x to the 3rd is x to the 3rd. X to the 6th divided by y squared is y to the 4th. So we're just subtracting, right? Plus 48. 48 divided by 8 is 6. X to the 3rd divided by x to the 3rd is 1. Y squared divided by y squared is just 1. So we have 3x to the 6th, y to the 6th minus 8x to the 3rd, y to the 4th plus 6 times 8x to the 3rd, y squared. That's factoring out the greatest common factor. Good? Okay. 24, 47, and 12. 47. Make sure 47 is a prime number, right? All right, if you get a weird one with 47, just look at your list of prime numbers. Oh, 47 is a prime number. That means there is no, nothing you can divide 47 by except itself and 1. So you can't divide 24 by 47, and you can't divide negative 12 by 47. So the greatest common factor would just be 1. P, there's no P here, there's no P here. Q, there's no Q here, there's no Q here. So we can say we can only divide it by 1. The greatest common factor is 1. But we also say that this is a prime. If the only factor common to the terms is 1, that is a prime polynomial. Prime. Can't be factored. All right. Factor a negative number out of the polynomial. Okay. So negative 6x minus 54, it sounds scary, but both of those numbers are negative, so we're just going to take out a negative. Sound okay? So negative 6 and negative 54. Treat it like it's positive 6. 6 can be 1 times 6. 6 can be 2 times 3. That's it. Right? So the factors of 6 are 1, 2, 3, and 6. 54. We only need to check these factors. Can you divide 54 by 6? Yes. 54 is 1, doesn't matter the rest of them, 6, 9, and 54, right? There are other ones, but of this list, we want the biggest of that list that is also on the list of 54. So we're just going to say the greatest common factor is 6, because this is a negative 6x and a negative 54. We're going to make that a negative greatest common factor. So we're going to divide out or factor out a negative. Negative 6x divided by negative 6. A negative divided by a negative becomes a positive. Negative 54 divided by negative 6, we said is 9. So it's not going to be minus 9. It's going to be plus 9 because a negative 54 divided by negative 6 is a positive number. 20 has negative 6x to the fourth plus 9x to the third minus 3x squared. What are the greatest common factors? Well, 3 is just 3 and 1, right? Can I divide 9 by 3? Yes. Can I divide 6 by 3? Yes. So I'm going to say my greatest common factor is negative 3 because negative 3 is the greatest factor of the number negative 3. Good. Now let's look at the x. X to the fourth, x to the third, x squared, negative 3x squared. It's up to you. You don't have to factor out a negative number, but they're asking us to factor out a negative number. You could also factor out a positive 3x squared if you want. But since the leading term is negative, we generally want the leading term to be positive if possible. So it makes sense to factor out a negative if both the terms are negative, or if most of the terms are negative, or even if the first term is negative. Okay. So remember, we start with the greatest common factor factored out. Negative 6 divided by negative 3. 6 divided by 3 is 2. X to the fourth divided by x squared is x squared. Positive 9 divided by negative 3 is going to be a negative 3 because a 9 divided by 3 is a 3, but a positive divided by negative is always going to be a negative. X to the third divided by x squared leaves me with an x. And then negative 3x squared divided by negative 3x squared. You can't leave it as a 0, but negative 3 divided by negative 3 is a 1. X squared divided by x squared is 1. 1 times 1 is just 1. All right, let's factor out the greatest common factor from the polynomial. Here we factored out negative 3x squared. Here we have the term x times y plus 15 plus 14 times y plus 15. What is the greatest common factor? Y plus 15. How do I factor out a y plus 15? I just put it out front like we've been doing. It just happens to be 2 terms. And then I'm going to multiply that, right? We take the first term and then we multiply everything else. Everything else is x and 14. Good. So that is the factoring out of the greatest common factor when the greatest common factor is y plus 15. Good. All right. W times z minus 11 minus 5 times z minus 11. My greatest common factor is z minus 11. So I'm going to put that on the outside. And then what's left? W minus 5. So it's like I did z minus 11, z minus 11, right? What's left? W times z minus 11, W. Negative 5 times z minus 11, negative 5. All right. So we already looked at 23 way back at the introduction, but we have been dividing out greatest common factors of 2, 3 terms. We can call them 3 terms. This one's 4 terms, but that's not what makes it different. We have 4x plus 40 plus xy plus 10y. What makes it different is there is no greatest common factor. So if there's no greatest common factor, but you do have 4 terms, we use factor by grouping, okay? All right, so how do we use factoring by grouping on a polynomial that does not have a factor common to all 4 terms? No factor common to all 4 terms, but if you group the first 2 terms together, that group has a greatest common factor. If you put the last 2 terms together, that group also has a greatest common factor. It also doesn't matter if you want to rearrange it. You're like, oh, 4x and 40 and xy and 10y. Well, I say that 40 and 4, you can divide by 4. Xy and 10y, you can divide by y, right? So you put them into 2 different groups, and you find the greatest common factor of each grouping. So here is group 1. Here is group 2. Okay. Or it will still work if you decide to move them. If you decide it's 4x and xy and 40 and 10y, now that's the first group. And that's the second group. It's a different pair of groups, but check each group, okay? 4x and 40, divide them both by 4. xy and 10y, divide them both by y. 4x and xy, divide them both by x. 40 and 10y, divide them both by 10, okay? So if you see a set of 4 numbers and you're like, I don't see a greatest common factor, feel free to move them, okay? Move the 2 middle numbers around. All right, so group the first 2 terms together. We're going to group the first 2 terms together and find their GCF. My first 2 terms are 4x and 40. That's my new group. The greatest common factor. 4 divided by 4 is 1. 40 divided by 4 is 10. So my greatest common factor is 4. Step 2. Group second. So second 2 terms just means those last 2. Group the last 2 terms together. In this case, it is xy and 10y. And find this greatest common factor. Greatest common factor, all I have is variables. The only variable that is common to both is y, and the highest exponent of y is y1, so my greatest common factor is y, right? Factor out the GCF. Right, so I decided that 4x and 40 has a GCF of 4. xy and 10y have a GCF of y. But it's still one problem, okay? I can cover it up and say I'm going to divide this one by 4. And I'm going to divide this one by y and factor out each of those, okay? But we're still, so it's easier, I would say, to look at it as like that, okay? So if we're just simplifying 4x and 40 divided by 4, remember we put 4 on the outside. 4x divided by 4 is x. 40 divided by 4 is a positive 10. Okay? xy and 10y, the greatest common factor is y. xy divided by y is just x. 10y divided by y is 10. Okay? Keep this sign the same. Find this GCF. Make sure to keep the sign from the middle with the GCF, okay? So if we are saying plus xy, it needs to be a positive y that we're factoring in. Keep the sign from the middle as the sign for your greatest common factor. If we happen to have 4x plus 40 minus xy plus 10y, we would want to factor out a negative y, okay? Keep the sign from the middle of your 4 terms as the sign of your greatest common factor. So we factor out each GCF, and we are left with 4 times x plus 10 plus y times x plus 10 plus the parentheses, right? So we factored out a 4 and we factored out a y, and we have another common factor between two terms. So now we have two terms, and we want to factor out the GCF of the two remaining terms. Four times the quantity x plus 10 plus y times the quantity x plus 10 becomes just like up here. Okay. 4 times x plus 10 plus y times x plus 10, factor out the greatest common factor, which is now x plus 10. Always put that greatest common factor out front. So x plus 10 times 4 plus y. Good. And you want to see, you want to make sure it works. Let's FOIL it. Okay. X times 4, 4x, x times y, xy, 10 times 4, 40, 10 times y, 10y. 4x plus xy plus 40 plus 10y. Is that the same? It is. These two got switched around, but it is the same. Okay. And if I had used 4x plus xy plus 40 plus 10y, right? I saw no common factors between 4x, or sorry, between 4x and 40 or xy and 10y, so I flipped them and do the same thing. Group the first two terms together and find the greatest common factor. 4x and xy, the greatest factor is x. 4x divided by x is 4. Xy divided by x is y. Group the second two terms together and find the greatest common factor, keeping the sign from the middle. So it's a positive 40 and a positive 10y, so I'm going to have to be a positive. 40 and 10, I can divide 10. 40 divided by 10 is 4. 10 y divided by 10 is y. So I factored out each of the greatest common factors, and now I have a greatest common factor of the two. And that greatest common factor is 4 plus y. I put that out front, just like I put the x out front here and the 10 out front here. The 4 plus y goes out front because it's my factor, and I'm left with x and 10. And that is the same, right? 4 plus y, x plus 10. 4 plus y, x plus 10. In the opposite order, but it's the same two terms. 4 plus y, x plus 10. 4 plus y, x plus 10. Don't be afraid to move them around if you don't if it looks easier to move them around. Okay? So factoring the polynomial by grouping, 7x negative 77 plus xy minus 11y. You just want to check, can I divide anything out of all of those? 777, xy, no, right? There's no common factor, so I'm just going to group them. 7x and 77. What can I factor out of 7x and 77? 7x and a negative 77. I can factor out a 7, right? So that's going to be 7 times 7x divided by 7 is x. Negative 77 divided by 7 is a negative 11. Okay, so that's my first group done. Second group is positive xy minus 11y. If that is a plus sign right there, that means this has to be a positive greatest common factor. Xy minus 11y, the factor is 11. The factor is y. Xy minus 11y, the factor is a positive y, because that is a plus sign, so that needs to be a plus sign. Xy divided by y is just x. Negative 11y divided by positive y is going to be a negative 11. So I factored out the greatest common factor from this side. I factored out the greatest common factor from this side. Now I see a greatest common factor of x minus 11. X minus 11 and 7 plus y. Good. And if you multiply that back out, you'll get these 4 terms. Okay. xy plus 10x minus 2y minus 20. Again, make sure there's no common factor to all 4 of them. xy, 10x, 2y. No, there's no common factor, right? First step, what is the greatest common factor of your first 2 terms? xy plus 10x. My only factor is x. Factor it out. xy divided by x is just y. 10x divided by x is a positive 10. Be very careful right now because I see that that's a negative 2y. So that means it needs to be a negative greatest common factor. We need to keep that sign the same. Okay. That sign follows the greatest common factor. Negative 2y minus 20, we can divide those both by a negative 2. My greatest common factor is negative 2. I'm going to divide it out. I'm going to factor it out of negative 2y minus 20. Negative 2y divided by negative 2 is a positive y. Negative 20 divided by negative 2 is a positive 10. See how now we have a common factor of y plus 10, y plus 10. If I had not kept the sign the same, if I had not kept the sign the same, this is what would have happened. xy plus 10x minus 2y minus 20. This side would have stayed x, so it would have been x times y plus 10. This side would have been a positive 2, so I would have said plus 2. Negative 2y divided by positive y would have been a negative y. Negative 20 divided by positive 2 would have been a negative 10. So the problem would have been that we wouldn't have had a common factor. That's why you need to keep this sign. This sign needs to match what you factor out, or else you won't have a common factor. This step. Okay. Divide out the common factor. It is y plus 10. And what we get is y plus 10 times x minus 2. Good? All right. So remember, that's a negative, that's a negative. You can still move those around if you want. The negative goes with the 2y. Okay? xy plus y plus 3x plus 3. Any common factors? There are not. My first 2 terms are xy plus y. I'm going to factor out a y. xy divided by positive y is x. Y divided by y, it's not 0, it's 1. Okay? That's a positive 3x and 3, so it's to be a positive greatest common factor. 3x and 3 has a factor of 3. Three x divided by 3 is x. 3 divided by 3 is 1. Those should always match, right? Then we factor that one out. X plus 1 times y plus 3. Final answer. Good. All right. This one's difficult. 15x squared plus 20xy minus 12xy minus 60y squared. If this has a 15x squared and this has a negative 16y squared, that doesn't have any common variables. And I know 15 and 16 don't have a common number that they can be divided by, right? So I need to factor by grouping. My first group is 15x squared plus 20xy. 15 and 20. 15, the only factors are 15, 5, 3, and 1, right? Of 15, 5, 3, and 1, the only number that can be divided by 20 is 5. X squared, x, y. There's one x raised to the first power, right? So if I take out a 5x, 15x squared divided by 5, 15 times 5 is 15 divided by 5 is 3. 5 times 3 is 15. X squared divided by x is just going to be x. Positive 20 divided by 5 is a positive 4. XY divided by x just leaves me with the y. Again, very important that we notice that's a negative, so this is going to be a negative number we factor out. 12 and 16. I can't take 16 and divide it by 12. What are some other factors of 12? Factors of 12. I can say 12 and 1, 2 and 6, 3 and 4, right? So those are factors of 12. Which one of those is also a factor of 16? 1 is a factor of 16, 2 is a factor of 16, 3 is a factor of 16, 4 is a factor of 16, 6 is not a factor of 16, 12 is not a factor of 16. I want to pick the biggest one because though I can use 2, I want to use the biggest one possible, okay? I'm going to say it's 4, and remember it's a negative because that was a minus. 16, 12 and 16 are both divisible by 4. X, y, and y squared, I can pull out a y. Negative 12 divided by negative 4 is a positive 3. XY divided by y is an x. Negative 16 divided by negative 4 is a positive 4. Y squared divided by y is just a y. Good. So now we see the common factor of 3x plus 4y. And what are we multiplying it by? We're multiplying it by 5x minus 4y. Good. Okay. 12x to the 6th minus 8x to the 3rd minus 15x to the 3rd plus 10. Like I almost could factor out of x, but we cannot. We can almost factor out of 2, but we cannot, right? So we'll factor by grouping. 12x to the 6th minus 8x to the 3rd. You can divide them both by 4, and you can divide them both by x to the 3rd. 4x to the 3rd. 12 divided by 4 is 3. X to the 6th divided by x to the 3rd is x to the 3rd. Negative 8 divided by 4 is a negative 2. X to the 3rd divided by x to the 3rd is just 1. Ooh, I don't have enough room now. Negative 15x to the 3rd. So it's going to be a negative number. The only number that goes into both 15 and 10 is 5. 15 divided by negative 5 is a positive 3. X to the 3rd. 10 divided by negative 5 is a negative 2. So now I have 4x to the 3rd minus 5 times 3x to the 3rd minus 2. Good. All right, x to the 3rd plus 9x squared plus x plus 9. X to the 3rd plus 9x squared, I can factor out an x squared. X to the 3rd divided by x squared is just x. 9x squared divided by x squared is 9. Plus x plus 9. Oh, what? There's no common factor. That's okay. It's a positive, just make it a positive. It's okay if it's 1. Plus 1. X plus 9. So what do we still have? We still have x plus 9. X squared plus 1. Good. And if you didn't like that, if you looked at that ahead of time and you were like, well, there's no common factor in the second part, flip them around. X to the third plus x plus 9x squared plus 9. That looks like it has better factors, right? X cubed and x have a common factor of x. X cubed divided by x is x squared. X divided by x is 1. Good? Here, 9x squared and 9, and it's a positive, so we're going to divide it by 9. 9x squared divided by 9 is x squared. 9 divided by 9 is 1. What we have is x plus 9 times x squared plus 1, which is the same. So it's okay if the common factor of one of the groups is just the number 1. It will still work. All right, last example, guys. This is a long one. What is different about our last example? 2x squared plus minus 10x minus 8x plus 70. What is different is, I will tell you since we're at the end and I'm tired, they're very tired, you can divide them all by the number 2. So before you go to group factoring by grouping, divide out the common factors. When factoring polynomials, always look for a common factor first. Good. So 2x squared minus 10x minus 8x plus 70 divided by 2 becomes x squared minus 5x minus 4x plus, what's 7 divided by 2? 3.5, so plus 35. And now we can factor this one by grouping. X squared minus 5x has a common factor of x. Negative 4x plus 35 has a factor of 1. So keep that 2 on the outside. X squared divided by x is x. Negative 5x divided by x is negative 5. Good. That looks the same as what we've been doing, right? Ooh, sorry, it shouldn't be 1, it should be negative 1 because that's a negative sign. Okay. Minus 1, negative 1 divided by negative 4x divided by negative 1, negative 4. Positive 35 divided by negative 1 is in, sorry, positive 4, negative 35. It appears, then we would close the parentheses. It would appear that this is not factorable by grouping. So you can find common factors, but if you don't then, after this step of finding common factors for your 2 groups, if you then can't find a common factor, it's not factorable by grouping. So we just call this 2 times x squared minus 5x minus 4x plus 35. You don't want, you can switch it around and it still shouldn't work. So that would be a way to check your answer, but it still should not work. So if we did 2 times x squared minus 4x minus 5x plus 35, then that becomes right? 2 times x minus 4 minus 5, x minus 7. Still doesn't work. So we just leave it as, I can factor out a 2, that's the factor of 1. Wait, what? No, it's not. Let's add those together. Negative 5x minus 4x is 9. Minus 9x plus 35. This is a weird example. Anyway, that is the simplest form of that. And I hope that that makes you feel confident about your math skills to see what a mess I made of number 32. Trying to find the right answer. Eventually got to like a more simplified form, but yeah, all we could do to this was combine the like terms of -10 and -8x, and then divide all three terms by 2. We end up with 2 times the quantity x squared minus 9x plus 35. All right, guys, thank you so much. That was a long one. I hope that you have a great day.